In this video, I'll solve two questions from the chapter Introduction of Trigonometry based on trigonometric identities of class 10th. So let's begin with the first part here. In the first question, we have to prove that sin raised to the power 6 theta plus cos raised to the power 6 theta is equal to 1 minus 3 sin square theta into cos square theta. Well, one thing is very clear that we are going to split this into smaller degrees, right? But then there can be confusion that I can write sin raised to the power 6 theta as sin square theta whole cube, or I can write this as sin cube theta whole square. Now, which is most suitable and which we should go for? Well, clearly we have an identity based on sin square theta and not sin cube theta. So we'll go for the first one here. First one by that. We'll be writing, let's say, I'll be modifying the LHS here also. I'm going to write sin raised to the power 6 theta as sin square theta whole cube, right? And not sin cube theta whole square. And likewise, I can write this as cos square theta whole cube. Now, what I'm going to do next is to apply the identity of a cube plus b cube. If you do not remember, it is a plus b bracket a square plus b square minus ab. Well, what is A for us? Clearly, this whole thing is A, right? This is our A here, and this whole thing is our B. So what is A cube plus B cube? As you can see, A cube plus B cube is A plus B. That means A is this plus B is this. So this is A plus B. Then what next? It is A square plus B square. Well, A is this, right? So square of this. So it's going to be what? Sin square whole square? Sin square theta whole square. That's A square. This is A square. And then plus B square. This is A square plus B square. B you can identify here is cos square. This is cos square theta. And then we have to place a square over it. So we got this as A square plus B square. And then we have to write minus AB. That means it is minus A into B, A which is sin theta, B which is not sin theta, sorry, sin square theta, and B which is cos square theta. Now, once we have applied this identity, that is an algebraic identity. What next? What you can write this as sin square plus cos square as. What is sin square plus cos square as? That's 1. And 1 multiplied by any number is the number itself. That's why I'll be ignoring this as this becomes 1. Now let's figure out what you can do from these two. For this, what you have to remember this identity which we have done in algebra, that is a square plus b square is what? A plus b whole square minus 2ab. Well, in case if you do not know this identity, what you can do, that's not an identity, it's a derived part. You simply write a plus b whole square. And what is it? It is actually a square plus b square minus plus 2ab. But then if you are looking for a square plus b square, I repeat, if you are looking for a square plus b square, then you're going to do what? You will transpose this to the left hand side. In turn, this will become minus. That's why I said that a square plus b square can be written as this. So I repeat, what we are going to do is to apply a square plus b square here. So a square plus b square is what? A plus b whole square. This is a and this is b, a plus b whole square minus 2 times ab, 2 times a which is sin square theta, b which is cos square theta, and this I am copying it, that is minus sin square theta into cos square theta. Right. So now same way as we have done this earlier also, that is sin square plus cos square is 1, right? So this time 1 square is there, right? So 1 square is 1. So I'll be writing 1 here minus, as you can figure out for the remaining, you can see from here that these are like terms, right? These are like terms. So minus 2 times sin square cos square, minus 2 times sin square cos square, and 1 times sin square cos square will give you how much? Minus 3 times sin square theta dot cos square theta. Then that's how we got the RHS here. So the trigonometric, besides trigonometric identity, you'll also have to remember the algebraic identities applied on working of this question. Now I'll go to the next question, that is question number 2. In the second question, it's sin square theta plus cos raised to the power 4 theta, and the RHS is cos square theta plus sin raised to the power 4 theta. Now the power is just opposite to each other. So we'll begin with say the LHS, and what I'm going to do is to write cos square cos raised to the power 4 theta as cos square whole square. That's what I'll do. So we'll have sin square theta plus, as I said, I am splitting this power, and I'll write cos raised to the power 4 theta as cos square whole square. Now check, this is sin square theta plus what I can write cos square theta as you know, cos square theta can be written as 1 minus sin square theta. Well, I'm doing so because we know that we have to get sin cos only on the RHS. So I'll be writing this as 1 minus sin square theta, and then there is a whole square. Now in the next part, let's say this be as it is, and I'm going to write this as a minus b whole square, applying a minus b whole square. Now this is a and this whole thing is b. So it's what? A minus b whole square is what? A square, right? A square, which is 1 square, plus b square. That means square of this, plus b square. Square of this is what? Sin square theta whole square. Minus 2 times a, which is 1, and b, which is sin square theta, right? So what I have done is simply applied a plus b whole square, right? Applied a plus b whole square here. Now what next? This is going to be sin square theta only, plus this is 1. And what about this? This is sin raised to the power 4 theta minus 2 times sin square theta. Check, we have like terms here. There is 1 sin square theta here, and there is minus 2 times sin square theta. So what I'm going to do, I'll write this 1 first. And what is sin square theta minus 2 sin square theta, right? It should give you 1 times sin square theta, that is sin square theta plus sin raised to the power 4 theta. This is power 4, right? This is sin raised to the power 4 theta. In the final step, you can work out this thing, that is 1 minus sin square theta can be written as cos. Well, I'm not going in a random direction. In each step, I'm looking into the RHS, and that helps me. I'm guided by what I have to prove. It's not a random way. So when I look into the RHS and when I saw this 1 minus sin square, that hinted me that we should go by this method. Now check here, as I said, 1 minus sin square theta is what? Cos square theta plus, and this is sin power 4, should be as it is, sin raised to the power 4 theta, which is equal to the RHS. So we'll say that LHS is equal to RHS.